Okay, let's start looking at circuits and figuring out how all of these relate. If you have a simple battery hooked up to a headlight of some sort, and it's a really simple circuit like this, current flows out of the positive terminal through the light and back into the negative terminal. Um, in circuit diagram sense, that would look like this. You've got your voltage V with your plus and minus side, and if the plus and minus aren't explicitly labeled, the long bar is the plus, the short bar is the minus. All right, so the I is the current and it's flowing from plus to minus in this. R is the resistance, and this is our symbol for resistor. It's just a little, it looks like a heating element, right? And that's kind of where it came from. Um, so we got a little resistor symbol or voltage symbol. We've got our current, which we usually draw an arrow to show which way the current's going. So how does all of this relate? Well, we have ohms to thank for that, and Ohm's law. Ohm's law is really voltage is current times resistance. And um, actually, I think he did this. Resistance is voltage over current. But this is Ohm's law. This is the basic right there. V equals IR. So the voltage and current and resistance aren't all independent of each other. Well, resistance is usually something you design, right? And we often use little bits of carbon for resistance. Metals don't have much resistance at all, which is why we use them for moving current over long distances. Um, Other things that are silicon has some resistance, and your LEDs, your LED lights have some resistance that in part takes into account the fact that they're shedding energy, converting energy from electrical energy into light. In a standard carbon resistor, you convert electrical energy into heat. And so you waste energy into heat. Why? Because those charges that are moving through it are bumping into things and actually causing them to move around and giving you heat as a result. Power is just voltage times current. So voltage is joules per coulomb. Current is coulomb per second. And so you multiply those together, you get joules per second, and joules per second is a watt, right? So power is voltage times current. So now we know how all of these quantities we've been talking about actually relate. Um, we've got V equals IR, and we've got P equals VI. And that gets us, and you can write this in different ways, right? You could use V equals IR. Well, voltage is IR. So I can come down here, I can stick in IR for V, and power is now I squared R. Or I can stick in for I is V over R, and so I go to power is V squared over R if I make that substitution for I. So there are different ways to write the power, but the fundamental definition is voltage times current. Okay, that's it for putting those pieces together. Now next we'll talk about how resistors combine.